Hey everybody, Monaco here. Our fifth lecture notes on chemical bonding. We're going to name ionic compounds here. I'm going to give you the naming rules, and nomenclature is a fancy way to call our naming rules. And so there's naming rules for ionic compounds, and they're related to the formulas of those ionic compounds. And I really wanted to, bring that to life here. So let's take a look. Nomenclature of ionic compounds, including polyatomic ions. We're going to hit all these up. So there's going to be 3 examples. I think you should probably watch first, save space, and then record, because there's a process here that you don't need to necessarily write down, but you do need to write down the overall answers and stuff. So maybe watch a video a couple times to really get the idea of what you should do writing down and what you don't need to write down. All right, so here we go. First name, middle initial, last name. Okay, ionic compounds always have 2 names, and sometimes they have a middle initial too. The transition metals are the ones that get middle initials for reasons that you'll see very shortly. First name. Let's do an example. You got a formula, FeCl2. What's its name? That's the whole point of this lecture notes. So you find Fe and Cl on your periodic table, and you're like, okay, now what do I do? Well, what we're going to be doing is we have been practicing ionic bonding diagrams, and so we know that Fe, atom with a bracket, we got to figure out what charge we need to put in there. Cl with a bracket, wow, that's funny, and Cl with a bracket. The reason why I drew this is because I know I have 1 Fe and 2 Cl's already, which makes it easy for me to figure out. The nonmetal Cl is going to be picking up electrons. So we know that the charge on the nonmetal is going to be -1. That's one of the rules of ionic bonding. Metal gives up electrons to nonmetal. So the nonmetals have a negative charge for their ions. So I know I've got -1 and -1. That's a total of -2 on my nonmetal side of the compound, which means that my metal side of the compound's got to be the +2. You see how there's 2 options? Well, iron is a transition metal, so it has to have an initial in middle of its name in order to show you that we're talking about the iron +2 ion, not the iron +3. So as I build the name, I am thinking in the back of my head, okay, I have 1 iron ion and 2 chlorine ions. It helps me figure out the middle initial for this particular compound. So let's see how it goes. First name, you always name the metal. In this case, iron. Middle initial. This is the Roman numeral that tells us the charge on the metal ion if there are multiple options. So in this case, we just realized that it has to be iron +2 because there's 2 chlorine -1s to cancel it out. So we put a Roman numeral 2 as its middle initial. And then the last part, the last name, we take the nonmetal's name and change the end of it to ide. So chlorine becomes chloride. And as a result, the true name is iron chloride. Iron 2 chloride, technically. And there it is. Let's do some more examples. Second example, CaCl2. So what is the name of that particular formula? Well, we're going to follow the same pattern. If you look on a periodic table, calcium only has 1 choice for the ion that it can form. It always loses 2 electrons to form a +2 ion. Since there's only a single option, it doesn't need a middle initial. Okay? Therefore, we no need for a Roman numeral in the middle of the name. I got to be honest with you, if you put it in there, I'm not going to be upset, but it's not really technically correct to do so. Only transition metals that have multiple oxidation states can form multiple different ions deserve middle initials. So, first name is going to be calcium, because that metal says its name. No middle initial. Second name is going to be chlorine turned to chloride. Done. Calcium chloride. Now we got to hit up a polyatomic ion. And these are actually a lot easier than you might think, because reference table E tells us all the names and charges of the polyatomic ions. Okay, so we got Ca and in parentheses CO3. You might see this written as CaCO3 or sometimes with the parentheses. So this could be this as well. They're the same thing. The parentheses are around the polyatomic ion to illustrate to you that this is something that's off table E, and you should go look for its name there. So CaCO3, what the heck would its name be? Well, the pattern is name the metal, calcium. Then you look at table E to name the polyatomic, which is carbonate. That's it. Calcium carbonate. Puts them together, and ba-dam! You have named a polyatomic ionic compound. Boom. There's a charge cancellation technique as well. That involves taking the name back to the formula, because you got to go both ways for fluency. First thing you got to do is you got to put out your element symbols, because those are going to be part of your formula. Na's for sodium, Cl's for chlorine, or chloride. Now you're going to find the charges off the periodic table. Remember, metals are positively charged, nonmetals are negatively charged, and they have to cancel out. This next step is going to help you figure out the formula very quickly and easily. So you cross the charges down. Watch. That 1 comes over to Na, and that 1 comes over to Cl. We drop off the positive and negative, because this is really a shortcut to finding ratios. Okay? So then we rewrite it over. We don't need the subscript 1 there, so we just erase it, NaCl. And this tells you the ratio of sodium to chloride is 1 to 1, which we started with realizing when we had our charges in the first place. So if you want to think about charge cancellation, you just got to think about ratios. How many negatives do I need to cancel my positive? And if that's not working for you, the crisscross method will. You drop them and swap them. Drop and swap. And then simplify. Drop, swap, simplify. Boom. Okay? Let's try an example. It's a little more complex. Calcium chloride. So element symbols. Calcium and chlorine. Okay. Go look up the oxidation states of those elements on the periodic table. Calcium has one option. Chlorine only has one negative option, so it's what we go with. Now the ratio here, as we can see, is going to be a 2 to 1. Swap and drop, and you get Ca1Cl2, which we simplify. We don't need to draw the ones. We could just do CaCl2. That's it. Okay. Polyatomics. Oh, no, iron 2 oxide. In this scenario, metal, iron, nonmetal, oxygen. Look up your oxidation states. Could be 2 or 3. We went with the 2 because the Roman numeral 2 in the examples. Oxygen's only got one option. So the ratio here is going to be 1 to 1. But when we swap and drop them, we get 2's down below. Well, we can find the common denominator between those two. Because remember, formula is about a ratio. So 2 iron atoms to 2 oxygen atoms, we can simplify that 1 to 1. Because for every 1 iron, there's 1 oxygen. Because that's the same as saying for every 2 irons, there's 2 oxygens. It's a simplified ratio. That's what all this last step is always about. So there's some pages, 12, 13, 14 in the practice pack to do. I really need you to try and do these on your own ahead of time, so when you ask questions, they're legitimate. I really got stuck on this one. Can you help me here? You're going to need a periodic table to do this and reference table E. So enjoy. Thanks for watching.